Hi, and welcome to the first lesson on Chapter 3, which deals with exponential functions. In these first types, we're going to look at sketching and analyzing graphs, describing its domain, range, intercepts, asymptotes, and end behavior, and then finally where the function is increasing or decreasing. So let's go ahead and first, in order to sketch our graph, we'll choose some x values to look at, such as we can choose -3, -2, -1, 0, 1, 2, and 3. And then for our y values, we're just going to put in 4 to the -3rd power. Remember that that is the same thing as 1 over 4 to the 3rd power. 4 times 4 times 4 is 64. So we would have a point at 1 over 64. And then 4 to the -2nd power in the same way will be 1 over 4 squared, which is 1/16. So we have 1/16. And then 4 to the -1st power is simply 1 over 4 to the 1st power. Remember, any function or any variable or any number to the 0th power is always going to give you 1. And then kind of following the trend, notice we're obviously multiplying by 4 each time. 4 to the 1st power is 4. 4 to the 2nd power is 16. And 4 to the 3rd power, as we said, was 64. So here are the points we can graph to begin sketching our graph. And when you do that, you should get something that looks like this, where you have, on the negative side, you have much smaller and smaller fractions that never reaches 0. And then on the right side, you're just exponentially increasing. So when we look at what we're trying to find here, we want to describe the domain. The domain appears to go to the left all the way, and nothing's stopping it from going all the way to the right. So our domain is from negative infinity to positive infinity. The range, though, does seem to have a limit. When we go down, it seems to be stopping at 0, never reaching 0. So we're going to put our range from 0 to infinity. Looking at, they want to know the intercepts and the asymptotes. Well, the intercept, where it crosses the x-axis, it appears that it never does, because you're never going to reach 0. You're just going to get bigger and bigger denominators, which gives you smaller numbers, but never approaching that 0 as far as the x-axis. So there's no x-intercept, but the y-intercept, it does cross the y-axis, where y equals 1 and x is equal to 0. So we have a y-intercept at the point 0, 1, or say where y equals where y equals 1. For the, let's see here, the asymptotes, like we said, it seems to never cross the x-axis. So we have an asymptote at the line y equals 0. Let's see. End behavior, as x approaches infinity from the left, or to the left, the limit seems to be approaching 0. As we approach infinity to the right, it looks like that graph approaches infinity. And finally, concerning our increasing and decreasing intervals, it appears that the graph going from left to right is always increasing. So it would be increasing from negative infinity all the way to positive infinity. So for the second example, instead of using the number table to graph this function f of x equals 5 to the negative x power, I'm going to recommend we just use our graphing calculator. And I got here in the y equals function on the calculator. And to put this in, we're just going to take the base 5 and then use the caret to denote an exponent. And I would recommend putting that negative x in parentheses just because the whole thing is the power. Just to kind of get used to that. You probably don't have to in this case, but and then we'll just go ahead and zoom and we'll check out standard, which is 6. And you can kind of get a good idea of what that graph is doing. When we look at this domain, it just seems to be uh, almost a mirror image of our previous graph from flipped over the y-axis. And when we go to the left, so you can actually trace this. When you go to the left, it appears we're just going to keep moving to the left at a very, very rapid pace. If you wanted to, you could zoom out and check that out. We're also going to see the same thing as the right. It doesn't seem like we're going to approach any sort of wall on the right side. So the domain is from negative infinity to positive infinity. And then the range, when you do look at that graph, the range appears to be definitely cutting off here. You notice we're getting super, super small numbers as we get closer to the x-axis for our y value, but we're never approaching 0, just like in the previous graph. And that should make sense because if you're putting in large values for x, you're getting large values in your denominator. And I would recommend, if you're not really seeing that, to go ahead and make a table of several values to convince yourself of that. And the range is going to go from 0 all the way up to infinity because that's just increasing exponentially. And the intercepts, there is no x-intercept because it's approaching the x-axis as an asymptote. But so we might as well write that in. We have an asymptote. The line y equals 0, or you could say the x-axis is your asymptote. But our intercepts, we have where x is equal to 0. So if I had 5 to the negative 0th power, there is no negative 0. So it's really just 5 to the 0th power, which is 1. So I could say I have an intercept at the point 0, 1, or I could just say my intercept is y is equal to 1. And then the end behavior, it appears as x approaches negative infinity, which I apologize. I earlier wrote the wrong notation there. I meant to say negative infinity and x approaches positive infinity for the function. So as we go to negative infinity, you can see the function is approaching positive infinity. And as we go to positive infinity, the function seems to be approaching 0. So then finally, the intervals on which the function is increasing or decreasing. It seems to me that as we go from left to right, the function's just constantly getting smaller and smaller on the y-axis. So we're not having any intervals of increasing, but we're decreasing from negative infinity all the way to positive infinity. So I actually have a couple of questions here for you to try on your own. This first one should be relatively straightforward. Just go ahead and see if you can recognize what the graph of 3 to the negative x looks like. Try it without your calculator. See if you can sort of figure that out logically. And then if you need to, throw it in your calculator and check your answer. And then the second question I have here is just, what we've been doing. Go ahead and once you've found that function, tell me about its domain, range, intercepts, asymptotes, and end behavior.